I have two lists here side by side that contain the exact same data with the exact same components. Each list is rendering over 5,000 items that are all CPU intensive. The one on the left has some input delay, can't even load any cards past this certain point, and look at that, it just crashed. The one on the right, on the other hand, is smooth like butter and is rendering all these items flawlessly, despite the fact that both left and right are using the exact same data and components. So what's the difference between the two? The secret is virtualization, which means only rendering the items that are on the screen and nothing else, which is extremely useful when dealing with large data. In our example, the list on the left is rendering all 5,000 rows at the same time, despite the fact that we can only see a few on the screen. On the right, only the cards that are being shown are actually rendered. When they're out of view, they unmount themselves from the DOM, hence significantly better performance. And it happens so fast that you don't even notice. Cool, so what's the trick? In this video, I'm going to show you exactly how to do this step by step by using TanStack Virtual. TanStack is primarily known for TanStack Query, aka React Query, but the same people made this virtualization library, TanStack Virtual. I could spend a ton of time talking about it, but let's cut right to the chase and I'll show you how to use it. To install TanStack Virtual in your app, go into the terminal and in the directory where you want it to be installed, run npm I at tanstack/react-virtual. Once that's installed, you're ready to go. I've set up a basic page in React here that renders out 5,000 cards, where it's just mapping over an array of objects that we're calling card data. I've disabled the artificial slowdown for now so the page doesn't brick on me again, but a situation like this where we have thousands of cards is perfect for virtualization. The core of TanStack Virtual is the virtualizer object. To add it into our code, we can just say const virtualizer equals use virtualizer imported from TanStack. And then inside the parentheses here, we can pass in an object where we can pass in some customization options. And there are three things that are required in these options. The first option is count, and that's the total number of items that we are virtualizing. For almost all cases, this count should be set to the length of whatever array you're mapping over. For example, if our array is 5,000 objects, that count should be 5,000. So since our array is called card data right here, we can set our count here to just be card data length. The next option here is estimate size, and this is exactly what it sounds like. How tall is each card over here that we're trying to render and virtualize? In my example, I believe each card is about 80 pixels. So what I actually want to do here is make a function that returns the size. So what to say function that just returns 80. And this is again in pixels right here. And this is assuming the height of these cards is fixed. For right now, we'll keep this assumption, but in a little bit, I'll show you how to take into account cards that may resize. The last option that we absolutely need is get scroll element. The whole point of virtualization is to be used within a container that can scroll. And depending on how we're scrolling determines which cards are being shown. So get scroll element needs to be the JSX element that is actually being scrolled. How you would typically do this in React would be by using a ref. So I'll actually go up here and I'll create a ref. I'm just going to call it const scroll ref equals use ref, just like this. And we'll make sure to go ahead and get this imported from React. And then for get scroll element, it's going to be a similar thing to estimate size. It's going to be a function that returns the element. So we're going to say function here, and it's just going to return scrollref.current, just like this. And we're most likely going to get a type error here saying the type is not assignable. So if we want to fix that, let's just default this ref to be null. And then let's say it can also be an HTML div element, just like this, so that TypeScript is happy. Next, we actually need to attach this ref to the scrollable element. So going down to our JSX here, let's assume that this top div right here is going to be the div that is actually going to be scrolled. So let's tag this ref on there. Let's say ref equals, and we're going to make it equal to scroll ref. Now our virtualizer knows which div is supposed to be scrollable. Now that we have this virtualizer all set up and ready to go, and we have this ref attached, let's bring our focus down to the JSX and we're going to get this virtualization set up, and I'm going to show you exactly how to do it step by step. In order for TanStack Virtual to work properly, there are three divs that you need to make this work, and we'll set up one at a time. The first div is the one that has the scroll bar, and that's the one we've already done. This div is going to be the parent of all the other ones, and there are some important things aside from the ref that this div needs to function properly. First, it needs to have a height that isn't unlimited, because the div itself needs to be scrollable, so we can't just allow it to grow infinitely. In this example, let's actually give this outermost div here. I'm going to give it a class name, and I am using Tailwind for this project, just as a side note. So I want to give it a height, let's just say like 90% of the viewport, and I actually want to do it for the width too. So I'll do size, I'll just say 90 dvh. And if I go ahead and save this page here, you'll see it got constrained. Let's not do that actually. Let's do a height of 90 dvh. I'm going to say a width of, let's try 3/4 maybe. Okay, let's do width full, and I think this should be good. The next thing this div needs, or at least should have, is overflow auto or overflow scroll, although I normally just use overflow auto. The combination of these two things, having a fixed height plus having the overflow of auto, will ensure that this div will become scrollable if there is overflow, which if we're doing virtualization, there definitely will be. So we'll go ahead and save this page here, and now you can see this div is scrollable and it cuts off here near the bottom of the page because it only takes up 90%. And again, having the hard-coded height is so the virtualizer can work correctly, but also it's a bit easier for me to show you how this works. Once we have this outermost scrolling div set up, the very next div that we need to add is one that is going to hold all of our virtualized components. And this div needs to have a class name, like the div here, needs to have a class name of relative. With regular CSS, that is just position relative. The only other thing that we absolutely need for this div to work properly is to give it a custom height. That height needs to be the total height of the entire virtualizer. Basically, it will be the maximum height that all of our virtualized items could be. Normally, the way that I do this is by using a direct style tag, instead of doing it in Tailwind, because Tailwind has trouble computing dynamic values like this. So in this style tag, what I'm actually going to write is height, set the height like this. It's going to be a template string here, and we're going to inject some JavaScript. We're going to say virtualizer, so we're finally using our virtualizer object, and we're going to call a method on it that's really useful, just called get total size, just like this. And this is a function, so we're going to call it like that. And at the end here, we'll just do px to let it know that this number is going to be in pixels. And this get total size does exactly what you think it does. It just returns, again, the maximum height of the virtualizer. I'll explain in just a minute why this div needs to be relative. But now that we have this, just to keep it organized properly, let's take this card here and let's stick it inside this relative div. So now we have two divs mapping our cards that we're going over. That is the first one, the scrollable div that contains the overflow auto and the fixed height. And the next one, the one we just did, the relative div that has a set height of the total size of the virtualizer. Now, inside this relative div that we just made is where the actual magic happens, meaning the actual virtualization. The most important aspect of this whole virtualization thing is that we don't just map over the array of things that we're mapping over, like card data, because then we're still going to be going over all 1,000. What we actually want to map over is the virtual items that our virtualizer is going to give us, which is where this virtualizer really comes into play. So how do we do that? We are going to get the virtual items out of this virtualizer by going down here and making a variable for it. So I'm going to say const virtual items equals virtualizer dot get virtual items. And it's really that simple. It is just a method that returns an array of all of our virtual items. These virtual items are going to be intelligently handled to render only the cards we need to show, which is the whole point of virtualizing, and exactly why we'll be mapping over virtual items right here instead of mapping over card data. So we'll do exactly that. Down here in our map, instead of doing card data.map, I am going to do virtual items.map. And instead of getting card out of here, I'm just going to get vitem, which is just short for virtual item. But what you name it doesn't really matter. The next question is now, inside of this map, what do we need to do? Well, the first thing to note is that this virtual item right here, this vitem, is not actually the item that we want to display. If we pull it up on the TanStack docs, we can see that it is actually an object with these following properties. And these properties tell us what number this item is, where it starts and ends to figure out its positioning, and how big it is. These things are going to be essential for getting our items positioned and rendered. But you're probably wondering, if these virtual items aren't actual objects that we're mapping over, how do we access those? Simple. We do it with this index that we're given right here, because this index is going to correspond to the index of the item that we're trying to get from card data. And let me show you exactly what I mean by that. Instead of just this map taking in a function that returns some JSX, I'm going to actually wrap this whole thing here in some curly brackets. And this is actually going to be a return. That way, that way, up here, we can write some code. So what I'm going to do first is make a variable for the object that we want. So I'm going to say const card, and it's going to equal card data. It's going to be at vitem.index. So if we are rendering a virtual item that has an index of 4, that means we are going to grab card data with index of 4. So it's going to correspond exactly to the card data. If it's the first one, so it's index 0, that means we're going to grab the very first card as well. This gives us access to the original objects we were trying to map over, but now it's accessing it through a virtual index. Now that we have this, there's one final thing. I said that there were 3 divs that we need to use, and we've already gotten 2 of them out of the way. So next up is the final div to make this work properly. And this is actually going to wrap around our card. So before we add anything to it, I'm just going to make a straight up div right here. Not sure why I didn't make a closing div. We'll do a div like this and plug our card right here, just like this. So now we have a div surrounding our card. The first and most essential thing for this div is that it has a class name of absolute, or a position of absolute. And then, just like we gave this relative div here, this style tag for the total height, we're also going to give this a style tag, except instead of doing height, we're actually going to make a transform property. This is going to get a little bit funky here. We're going to make another template string right here. And in here, what we're going to do is we're going to say translate y, and then inject some JavaScript here, and actually do some parentheses like this. And then in here, we're just going to put v item.start, and then that'll be in pixels. And actually, my bad, this pixel should be inside of here, just like this. This is going to vertically translate it. Now, let me stop you for a second. Before we go any farther, just so we don't get too lost in the sauce, now that we've got our 3 divs here, let me explain how all of this works from a positioning standpoint. This div right here is absolute, plus has a translate y, because our virtualizer gives us the exact start and end point of each virtual item should be. Again, if we go back to our virtual item, we have a start point and an end point. What we're doing with this absolute and translate is that we're manually pushing each card to the exact start point it should be at. For us to get this kind of translating and positioning is why we need it to be absolute and why we need it to have a translate y property. And an element can only be truly absolute if its parent is a positioned element. Hence why we gave this parent right here a class name of relative, or a position of relative, because this div is going to serve as the positioned parent of every single absolute div. I know this might be a lot to wrap your head around, so I've set up a super basic visual example. Imagine we have a rectangle area where we are going to virtualize some items. For the sake of this example, imagine this is our relative div. Then we are mapping out over some card components inside this rectangle. Imagine each card is 100 pixels tall. That would mean the start point of the first card would be 0 pixels from the top, the second would be 100 pixels from the top, the next card 200, and you get the picture. That's exactly what this code is doing right here. We have our relative div that is holding all the cards, mapping out a bunch of absolute divs that are each being assigned to their appropriate start point. And I think it's going to make more sense the more you use it and once you see it in action. Now back to the code. So this works right now, but we need a couple of more things to make sure this looks how it should. It's probably a good idea to first give this div here, this absolute div, a top 0 and a left 0, just to make sure the start point and alignment of the cards is consistent. Next, let's make sure our cards are hard-coded to be the appropriate size. So in our style tag right here, in addition to doing just the transform, I'm going to have a comma here for another property, and I'm just going to call it height, just like before. And for this height, what we're going to do is we're going to say we want the height to be equal to the size of the virtual item. So vitem.size, and that is going to be in pixels. Save this to get some formatting, and this will ensure that each card takes up the entire height and size that is stored in the virtualizer. We'll address this blank page issue in just a second, but before we do that, just to make sure React doesn't throw us any warnings, let's make sure we give this a key since we're mapping over it. And remember, our virtual item actually has a key on it, so I can just say the key is going to be equal to vitem.key. And just to directly plug the index into the DOM so it's easier to see, I also want to do a data index, and I'm going to set that to vitem.index. So now when you open our DevTools, you can see the index of each item. And now if we save the page, you can see our page is still blank. And I actually think the issue might be with our with full up here. Sometimes with full doesn't behave nicely. So let's also just give this a width of 90 dBW, just so it can be hard coded. And oh, there we go. Now if we save it, it looks like all of our cards are back. First things first, notice how all of our cards are kind of just jumbled together in one big mess. If this happens, that usually means that your estimate size when we made our virtualizer is probably a little bit too low. So let's change our estimate size from 80 to, let's say, 120. Go ahead and save this page now. And we can see this actually is a bit too big now because there's too much space. So let's bring it down to 100. Save this, refresh. And you can see this is looking a bit better. And lastly, to fix the problem of all of our cards being different widths, let's actually go into our absolute div here. And I'm just going to add width full, and that should make them all the same length. And now we're all ready to go. It's a bit of a grind setting up all these different divs, but once you have them set up, the virtualizer just works, and it works like absolute butter. If I make sure all this is saved and I go over to our page now and I just start scrolling, it looks fairly normal, right? Seems like a lot of work for a normal scrolling list, right? Here's the cool part. If I actually go open up our dev tools here, I try and expand this as much as I can. Let's go, let's go back into it. Let's shrink this down, make sure this is expanded enough where we can still scroll. You can see the dev tools here. And let me zoom this in. I'm actually going to open this up here, open up our relative div, and I want you to notice something. If I expand this a little more, just so you can see the data index here, you can see we have data index 0, 1, 2, 3, 4, and so forth. Watch this. If I scroll to the bottom of this, notice how 10 is the highest data index that we have. As I scroll down, 11 pops up, and then 12, 13, 14, 15, 16, you get the picture. And as I do that, notice this. Now the earliest one we have is 6, not 0. So essentially what is happening is they're virtualized. At the start, the first one is 0. As we scroll down, that one goes off the screen, unmounts, and it starts mounting the ones near the bottom. Again, this is exactly what virtualization is, and it's exactly what we want. This is ensuring that only the cards that we're actually seeing on the page are the ones that are being rendered. If these cards were super complex, this should give us a massive performance boost if we're doing this instead of mapping out hundreds of expensive cards all at the exact same time. And especially if you're doing any sort of data analysis with spreadsheets or anything along those lines, this kind of technique is going to be essential. And I'll also show you, if I go and close these dev tools and I just start scrolling, you can't even tell that it's virtualized. The unmounting of ones at the top and then subsequent rendering of ones at the bottom as they come into view happens so quick that you don't even notice it. I'm scrolling as fast as I can here. Let me actually get this scroll right here to go faster, and look how fast they're all rendering and unmounting. Now, I go back into our dev tools here, make sure they're wide so you can see them. And if we look at our data indexes here, 462, 463, 464. So basically nothing before index 462 is mounted anymore, which is going to be, again, a huge performance boost. And we're only rendering to this number, and that again will keep changing as we scroll. Now that you know this works, let's now go back to our code and go over a couple of things. First, you might be wondering, what if we want our virtualizer to be horizontal instead of vertical? Like if we had a carousel type component or just a horizontally scrolling one. Super simple. In our virtualizer setup right here in this object, we can actually pass in a Boolean. It's actually called horizontal, and just set it to true. And then the next big thing to make sure this works is to make sure instead of doing translate Y, we're going to do the opposite. Instead of translating Y, we're going to translate X. And it's important that if you're doing a horizontal virtualization, that you have a fixed width for the outermost div, which luckily we already do. And I can show you this. It's going to look super ugly because this is not formatted to look like it should to have horizontal scrolling in this example, but this is the basic picture. You can see the scroll bar shrinking because we're virtualizing more stuff. Again, it's going to look super, super ugly because these cards aren't made for that. But if you wanted to do horizontal virtualization, that is how you would do it. Also, this is just a syntax thing here, but I don't like having to access a bunch of properties from a single object, like having to do vitem.index or .star.size. That gets kind of annoying to me. So usually instead of doing vitem, I will actually destructure this and just take everything out of it. I'll just say index, start, do the IntelliSense here, key, and then we got size. And then for here, where we have the v items, we can just delete those and have just the variables themselves straight up. The next thing that you might be wondering is, what if we want an entire page to be virtualized? Right now, it's just constrained to this box here, which looks like most of the page because it has a width and height of 90%. However, it's not the whole page. It is constrained ultimately by this div. But what if the virtualized items were, for instance, on a dashboard that took up the entire width or viewport of the page? In that case, it's actually super easy. Instead of using the use virtualizer hook, we're going to use the other hook that TanStack Virtual provides. That's use window virtualizer. That's just imported, again, from TanStack Virtual. Now you're going to notice whenever we take that away, we're going to get an error here saying that get scroll element doesn't actually exist on these options. And that is because this use window virtualizer makes the scrollable div the entire HTML window, which actually removes the need for this get scroll element. So if we're going to do the actual entire window that we're virtualizing, we can get rid of this scroll element. I will just comment out this scroll ref for now, and we actually do not need this outermost div at all. I'm going to change this from a div just to be a fragment. And by doing that, now our entire page should be virtualized instead of just inside the box. So if I go ahead and save this, and maybe in hindsight, we shouldn't get rid of our width for this div. So it's actually, I'm going to get rid of just the height here. And I'm also going to get rid of the scroll, but we'll keep the width so it doesn't look all condensed like this. Go ahead and save it. And now it looks similar. However, now the entire page, or I should say the entire window is being virtualized, not just the div or the box that we were looking at before. So the general rule of thumb is if you want all your virtualized items to be constrained within a single div or some sort of box, then use the use virtualizer hook. On the flip side, if you just want the entire page or the HTML window to be virtualized, use the use window virtualizer hook. And then it just simply works. I can show you the exact same thing I showed you before. If I go into our console here, look at our items, you can see these are all being virtualized in the same way we were before, where they're being unmounted at the top and mounted at the bottom. Same exact thing is happening. Before we end this video, there's one more big thing that I want to talk about, and that's the answer to a question you may have already thought of. What happens if these virtualized items, in our case these cards, aren't all the same size? Or what happens if we have no idea what the size is going to be before we render it out? For example, as you can see right here actually, these two items are actually two separate cards that look very close together because this card is overflowing into two lines of text rather than just one. Another issue that might arise is if the virtual items have the ability to resize themselves. For example, I've actually added a feature on these cards where I can click them and they open up this little white space below it that has some more information. However, as you can see, obviously, when I click this, it looks pretty bad. This white is supposed to be part of just this card and it should push everything else down. But our virtualizer doesn't take that into account because it only takes into account this number over here. So that's why it's going to go behind this card and it's going to look really ugly. In other words, if we structure our code like this and our cards can resize and we just have this estimate size here, it's hard coded like this, our virtualizer is going to break. Let me show you exactly how to virtualize items that either have an unknown size or a size that is going to dynamically change. The first and most important thing right off the bat is this absolute div right here that wraps around all of our cards. We actually want this absolute div to be moved up one entire layer. And by that, I mean moved up above where we're mapping our stuff. And I'll explain why in just a second. So I'm going to take this div here. I'm going to paste it up here. Make sure our closing div's in the correct spot. Get rid of this one. Go ahead and save it. And now we've just moved our div up to the correct layer. And we're actually going to remove this key and data index off of this div. We're going to put it somewhere else in just a moment, but it does not need to be on this div. Let's go ahead and delete that. And we're also going to delete height too, because we don't need that. The one thing we will keep is all this absolute stuff. Plus we're going to keep this translate Y. Except now the obvious issue is that we're actually outside of the map. So we can't use the start from from V item, because that doesn't actually exist. It's going to say cannot find name start. What we actually want to do, instead of getting start, we just want to get the start of the very first item. So what we're going to do, say virtual items, the first one, and then get the start of that. And this could be undefined. So we're going to give it an optional, and we're going to give it in the optional chaining operator. And then let's just default it. Let's say if it is undefined, let's just put it at 0 pixels. And now that that's done, we have just one more thing to do. Let's go back down to our return here. We still need to use the data.index and whatnot that we just deleted off of this div. So we're actually going to make another div in here. Let's change this back to have parentheses here. This here, here. And we're going to wrap this with another div. And my formatting is getting all messed up today. Put this here. So we're having another div to surround our cards. You can see if we save it, our stuff is back on the page. First, in order to make this look a little bit better, let's just give this a class name. Let's give it some vertical margins for each card. So we'll say MY of 6, just to space them out a little bit. As you can see, we're already looking a lot better. Now, in addition to just doing a class name here, we're going to smack that key and data index back on this div. So we're going to say key equals key, data index equals index. And now we actually don't need size or start, so let's just go ahead and get rid of these from our destructuring here. And now here's the most important part to make this actually dynamic. On this div here, in addition to passing in the key and the data index, what we need to do is we need to give it a ref. And for this ref, all that we need to do is pass in virtualizer dot measure element. Measure element is exactly what it sounds like. It gets the size of the element that is attached to. And just a word of advice, measure element works in tandem with data index right here. So make sure if you have measure element like this, which you should also have a data index, because that helps the virtualizer identify which item in the virtualizer needs to actually be measured. So if I go ahead and actually save this page now, I want to run some testing to show you how good this works. Right off the bat, notice how no two cards are overlapping each other, disregarding the fact that they expand. Just by themselves, you can see they look properly spaced out. So now if I go ahead and click one, you can see what actually happens is it pushes the one below it down. I'll do it again with this card, and this one, and this one, and you can see it is properly pushing each card down farther in the virtualizer, which is exactly what we want. Now let me close these, and I can actually show you firsthand how this is actually working with the virtualizer. So let's go back in here, and I'll have this where I can at least open these. So let me open up this div here, and you can see we have the indexes 0 through 6. If I open one of them here, notice how 6 gets cut off. Now we only have 0 through 5. Click this one, now we only have 4, and then 0 through 3. This is because, let me go down to just one more card. As soon as I open a card, that means that one card is going to grow much bigger. And we're telling our virtualizer, hey, this card is bigger now, so the virtualizer needs to adjust for it. So the virtualizer says, oh yeah, you're right. That means we can't render as many cards anymore since this one is taking up as much space. If I click more cards in this view, notice how we're going to see even less cards being rendered in the inspector. And that, my friends, is how you do dynamic virtualization, where you can render things that are going to change sizes or render things where you don't know how large they are going to be. This also works great if you have responsive design, meaning your data is going to grow or shrink depending on the screen size. Now that you've used TanStack Virtualizer, I don't think you'll want to go back to anything else. Yes, it's a bit confusing the first time you run through it, looking at all these different divs, but once you think about the setup, it makes sense, and it's going to be a similar structure any other time you want to use it. And from there, the virtualization just works. I hope this video was able to help you learn something, and I highly encourage you to try out this library. Take care, everyone, and I'll see you soon.